Okay, we're going to be doing LeetCode 88, merge sorted array. So you are given two integers, arrays nums1 and nums2, sorted in non-decreasing order, and two integers m and n representing the number of elements in nums1 and nums2. So merge nums1 and nums2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the elements that should be merged, and the last n elements are set to 0 and should be ignored. Okay, so this is very verbose, but this is nums1, and this is nums2. As you can see, nums2 has a length of n, which is 3, and nums1 has a length of m plus n. In this case, it's 5, right? 1, 2, 3, 4, 5, 6. Oh, 6, sorry. 3 plus 3, 6. So they want you to merge and produce such an output, but it has to be in nums1. And you don't need to return anything. As you can see here, do not return anything. Modify nums1 in place instead. So there are two ways of doing this. And the first one is to have a result array, right? So you have a result array in which you insert you iterate through nums1 m time, from left to right until m, right? And then you iterate through nums2 from left to right until n, right? But and then your result array will evaluate to this. It will turn into this, and then you'll copy it back into nums1, right? So let's do that. So we initialize, we instantiate our result array. Let's call it our merge array, okay, our result array. And then we create two pointers to get to iterate through nums1 and nums2. So call one I. We initialize them to 0 because these indices start from 0 to whatever, right? 0 to whatever. So I will be for nums1, j will be for nums2. So now we iterate through. How do we do this? While I is less than, what's the length of m of nums1? The values, it's m, and j is less than n, right? We don't use or, we use and. So what do we do? If nums1 at index I is less than nums2 at index j, then we want to put the smaller value inside here. So result dot append nums1 at index I, right? Else, if it's less than, or if it's equal to or greater than, then we'll just append nums2 at index j. But whenever we append from a certain value, we need to increment. So I plus equals 1, j plus equals 1, right? So now once we're done merging, there's the possibility that because m and n may not be the same values, may not be the same lengths, it's possible that one of them may finish before. And that's why we used here and. So if one of them finishes before, that means we simply add all the remaining values in either nums1 or nums2 to the result array. So we add remaining values if they exist. It will be either in nums1 or nums2. So, but we can't tell which one is larger and which one is smaller. So while, not if, while I is less than m, in the event that it's nums1 that has more values remaining, we are going to simply add the remaining values. So result.append nums1 at I, and then I plus equals 1. And this will terminate when I is equal to or greater than m. Then again, we do while j is less than n. So again, result.append nums2 at j plus equals 1, right? So now that we're done, our result array will contain the values, right? It will look like this. But they told us, do not return anything, modify nums1 in place instead. So we copy result into nums1. So nums1, so I tried a few Pythonic options and they weren't working. So what I'm going to do is I'm going to do for I in range, length of result is going to be nums1 at I is equal to result at I, right? One of the things I tried was nums1 is equal to result that, but it didn't work. So, nums1, sorry. And voila, it works, right? So let's try and submit it. It works. So that's how we do it. But there's a difficult follow-up which asks us not to have this, right? But before we do that, let's try and see if this will work. Because I used to use it and it would work. So let me see. I called it nums, so nums1. No, it doesn't work. It doesn't work. So the follow-up is to do it in place, right? And the way we do it in place, since there's a space here, right? We can start iterating. We can have a pointer to this location at the end, and then we start iterating from this index for our j and this index for our I, right? And by the time we're done, we'll have filled up this whole array up until this position with the value of with the correct values, right? This one will only be filled up with the correct value if it was less than this. And then we have to check for that edge case. So let me show you what the code looks like. So we initialize 3 pointers. I is equal to, I will be for nums1, m minus 1. J will equal to n minus 1. And then we'll have the pointer for the end of nums1, right? Because now we don't have a result array. We're trying to fill this up by the larger ones at the end, right? So we're going to, instead of like adding to nums1 in increasing order, we'll add in decreasing order. So which one is the larger one? right? So we'll call it end is equal to length of nums1 minus 1. So this is our pointer here. So we'll iterate through from here to here and here to here, adding the largest ones to our end pointer. So while I is greater than or equal to m, and j is greater than or equal to n, right? Because we also want to compare at the 0th index, right? So we reduce them until. So while that is the case, we find the larger of the two. So if nums1 at index I is larger than nums2 at index j, then we want to put the larger of the two numbers here, right? So sorry, I would have done a sketch, but my pen isn't, my iPad pen isn't charged. So that means we add the larger to the end, So that will be nums1 at index n is equal to nums1 at index I. And then we increment, which will be I plus equals 1, no, minus equals 1, because we are moving backwards, right? Like this. And then we also decrement our end, because we filled in this, we come here. Else, if nums1 is less than or equal to, then we choose nums2. So nums1 at end is equal to nums2 at j. Then again, we do j minus equals 1, end minus equals 1, right? So once we're done with this, it won't change this last digit. Or, for example, if n was like super small, there'll still be some remaining values here, right? So what we have to do is we come down here and we say while I is greater than or equal to m, okay, I need to look this up. You see, okay, so for j, okay, we simply have to do it for j, not for m, because for m it will be, we have to do it for j. And the reason is, how can I put it? The reason is that nums1, we're going to reach the farthest end of nums1, right? But then nums2 may still have some values, right? In the event that nums2 is larger or this last value here is smaller, right? So we simply have to add the remaining values from nums2. So this will be nums1 at where end is equal to nums2 at j, and then j minus equals 1, end minus equals 1. Huh. Where did I make a mistake? Yeah. Sorry. This was less than or equal to 0, not n. It has to be greater than or equal to 0. Sorry about that. And voila, that works. Holy shit, what other mistake did I make? Okay, so I must have made a mistake somewhere. End is m plus n minus 1, m plus n minus 1. So where did I make a mistake? While j is greater than. Oh, yes, there's still the error here. Okay, it has to be greater than or equal to 0, not greater than or equal to n. That was silly of me. It has to be greater than or equal to 0. My bad. But yeah, that's it. So this is doing this in place is quite tricky, but yeah. All right, done with this. The time complexity is O of n, but space complexity of 1. Of m plus n, actually. All right.